Today we are going to see the concept of basic function of a computer. So in the computer architecture, this is the important topic. In this, we are going to see the basic function of a computer, that is how the computer will execute all the instructions inside the processor. That is the main function. So the main concept of function of computer is in order to execute a given task as per the appropriate program. The program is nothing but it consists of several instructions which are stored in memory. So in the memory, we can have data as well as the program. And this is a typical instruction that indicates the function of a computer, like add or not comma LOCA. That LOCA is nothing but location A, which is nothing but it's a memory address. So as per this instruction, the content of this location A will be added along with the register R0, and the result will be loaded in the place of R0 itself. So this is the flow it follows. So the basic operations like addition, subtraction, multiplication, division are happening in earlier computer. So this instruction add R0, LOCA. LOCA is the memory location. So it just add the operand at the memory location of location A. That will be added along with the register R0, and the resultant will be stored in the place of R0 itself. So this is the process happening inside the instruction. And the next example is load R2, LOC. As we already discussed, LOC is the memory location. So as per this instruction, the content of the location LOC will be moved on to the register R2, which is indicated in the left direction. So load is nothing but it's the equivalent operation of reading the content. That is, the content of LOC move on to R2 register. That means we are loading the value from LOC to R2 register. So this is what happening inside the computer. So we should know the basic concept in a computer. There are four steps. That is fetching, decoding, execution, store, or write back. This is the flow it just follows. So fetching is nothing but fetching the instruction from instruction queue, and that will be move on to the processor unit. Depending upon the ALU and register unit, it performs the operation. That means the decoding and execution process is happening with the help of ALU unit and the register unit, and the resultant will be stored in the place of register or memory. So load is the equivalent operation of reading the value from any memory to any register, or in other words, we can say register to register. So as per this example, which is given on the slide, it indicates the content of LOC move on to R2 register. That is what is happening inside the instruction. And the next one indicates the add instruction, or add R4, R2, R3. So as per this example given in the slide, the content of R2 and R3 will be added along with the R4 register, and the result will be stored in the place of R4. And the left direction indicates the destination, and the last two direction indicates the source, that is R2 and R3. R2, R3 is the source register. So the content of R2 and R3 register added along with the R4 register, and the result will be stored in a place of R4 register. And the next instruction is store, that is store R4, LOC. So here LOC is a memory location, and this R4 is indicates the register content. The store instruction, it's like a writing, like how we define load is a read and store is equivalent operation of write operation. So R4 is a register that contains a value. That value goes to LOC memory location. And this diagram shows the interrelation between all the units inside the computer system, and this shows the connection between the processor and memory. So in this slide, we can understand the memory unit is bidirectional with the system bus as a system bus as well as the processor unit, as well as input output unit is also a bidirectional with system bus and the processor unit. And MAR is nothing but memory address register, and MDR is memory data register, and control unit KL unit. So memory address register, which indicates the address location of input data or output data, that it's going to be connected with the system buses, and PC is the program counter which will point out the address of the next instruction to be executed. So whatever instruction we are executing inside the program, the instructions address are pointed out by this instruction PC. And IR is nothing but instruction register, which holds the address of the current instruction which is being executed inside the processor. That is pointed out by IR. And MDR is a memory data register which holds the data. And data memory addresses are stored in the place of MDR. And general purpose register which starts with R0 to Rn-1. So all the basic operations are using the registers of general purpose register which starts from R0 to Rn-1, and control unit indicates the control signals where it has to fetch, where it has to store, where it has to read the value, write the value. So all the signals are generated from this unit. And at last, ILU unit is mainly useful for performing the arithmetic and logical operations inside the computer. So this diagram shows the interaction between the computer and this diagram shows the interaction between the processor and the main memory inside the computer. So this detail about the basic operational concepts in computer architecture. Thank you.